Number 40, integral of 1 over square root of 4y squared minus 4y minus 3 dy. Okay, so I don't see a substitution that I can easily do, even though it might be doable, but I don't see an obvious one to make. So I'll come back to that if I need to. I kind of don't want to do integration by parts. This seems difficult. Not a trig integral. Maybe we could do a trig sub if we do some completing the square business. And it's not a nice rational function that we know how to do partial fraction decompositions at this level of math. All right, so let's attempt the completing the square method. So I'm going to complete the square on the side. So remember the first rule for completing the square, this constant out in front of the square term needs to be a 1. So let's factor out the 4. So it'll be y squared minus y minus 3/4. Okay, so if we want to complete the square, y squared minus 1 over 2. Okay, so minus y, and then plus, we want minus 1 over 2 squared, like that, which would be a 4th, correct? So plus a 4th, but we need to make it equal to minus 3/4. So what do we have to do? We subtract 1 to make it equal. We didn't change anything. Okay, so we can write this as 4y minus half squared minus 1, okay? And by the way, since this is under the radical, we can even, let me write it first, just to show you, not to jump too many steps. 4y, so let me write it as the y minus half squared minus 1, okay? So we can write this as root 4 times root of the other stuff, so we can bring this out as a 2 on the bottom, just to make it a little nicer. Okay, so now we have this. Oh, don't forget my dy. Okay, so now let's do a trig sub. You could do a little u substitution if you want, so that you don't have a y minus half, but you can just do a trig sub directly from here as well. Okay, so I have something squared minus something squared, so that means y minus half is the hypotenuse. 1 is one of the sides, and the square root of y minus half squared minus 1 is the last side. Okay, so let's substitute everything in the integram in terms of theta. So we need y first. So y minus half is equal to tangent, that's not tangent, that's secant theta. Actually, we don't need y, we need dy, which would be secant theta, tangent theta, d theta. Okay, and then we need the square root term. I'm not going to write the whole thing out. What's the square root term? That is tangent theta. So we have half integral dy is secant theta, tangent theta, d theta. That's all on top. And the square root term we said is tangent theta. So these tangents cancel. We're left with just secant theta, d theta. Okay. And what's the integral of secant? That is ln of secant theta plus tangent theta in absolute values plus c. All right, now let's back substitute. We squeeze it in. Half ln of what secant theta? That is the y minus half. We have it right here. Or we could look at the triangle. Doesn't matter. Okay. And then plus, what's tangent theta? Square root of y minus half squared minus 1. That's all in absolute values. Plus c. Let me double check this is correct. Well, at least matching what I got previously. Yes. Okay. And of course, if you want, you can rewrite the square root term a little nicer, but in the interest of time, especially if you're on task, don't bother doing it. If you need to, if you have time at the end, then by all means, go back to do it. All right? Okay, that's it for this video. Hopefully this was helpful. This is a very typical completing the square type of problem for a trig sub.